Okay, today we will study review chapter 6 physics 11th grade. In this chapter we will review almost almost rules in this chapter. First rule, the relationship between number of electron and charge. Uh, the question is how we can find number of electrons in a point charge. Of course, here it's clear in this slide there is a question, find number of electron in 5 microcoulomb. So the amount of charge here 5 microcoulomb. Firstly, the question is equation is number of electron E equal Q, this is amount of charge divided by the charge of electron. Number of electron equal 5 times 10 to power negative 6 coulomb. Why times negative 6? Because the question clearly asks about micro. So microcoulomb should convert to coulomb. By what? By times 10 to negative 6. What is this? 1.6 times 10 to negative 19. This is constant charge of electron. This is constant. Some scientists they said this is a universal constant. Okay, after use calculator, the answer is 3.1 times 10 to power 13. This is a number of electron. Let we go to the next slide. In this slide, Coulomb's law, this is second rule in this review. I remember the rules of Coulomb is F force, electric force equal Kc, constant Coulomb, times Q1 times Q2 divided by R squared. What is Q1? Charge number 1. What is Q2? Charge number 2. What is R? The radius between two charges. Here, of course, the question is if we have two charges, positive 2 microcoulomb and negative 5 microcoulomb, which are separated by distance 10 centimeter. Now, look at this graph. Two green charges. This is positive 2 microcoulomb on the right side and negative 5 microcoulomb at the left side. The distance between them 10 centimeter. Question A, which type of electric force? Of course, we have two types of electric force, either attraction force or repulsion force. Because in this case, we have two different sign charges. I mean, one charge positive, the other negative. So in this case, we expect the attraction force between them. Type of force is attraction. B, calculate the magnitude of the force, of this force. We have to use rule. But before we go to the rule and solution, remember each microcoulomb should change to coulomb by multiply 10 to power negative 6. and this distance 10 centimeters should convert to meter. It will be 0.1 meter. Let me go to solution. Here the solution of the previous question. Here A, because there are two different charts, so so there is an attraction force between them. We need to rule F equal Kc K1 times Q2, sorry, Q1 times Q2 over R square. As I said, F force, Kc constant of Coulomb, and Q1 first charge, Q2 second charge, R the distance between them. I said every time put instead of Kc 9 times 10 to power 9. In questions, monthly question, final question, teacher will put this number as a constant of Coulomb in the questions. So here instead of Kc 9 times 10 to power 9 and first charge 2 times 10 to negative 6, second charge 5 times 10 to negative 6 divided by 0.1 square. Use calculator, then the answer it will be 90 centimeter, 90 Newton, 90 Newton, because this is force, electric force. Now let we study another slide. In this slide there is electric field. This is general formula of electric field equal force divided by charge. Here let we take question 1. Find the strength of electric field due to a charge of 10 nanocoulomb at a point if the force in this point, of course, electric force equal 40 Newton. So here what is given for electric force given 40 Newton and charge equal 10 nano. If you remember, we need to convert this nano coulomb to coulomb. Nano coulomb convert to coulomb by what? By times 10 to power 9, negative 9. So E equal F over Q. So instead of F equal 40 Newton divided by 10 times 10 to negative 9. After we divide and simplify, the answer is 4 times 10 to power 9 Newton over Coulomb. Question 2. If the strength of electric field here given 17 Newton over Coulomb due to from charge, of course, this charge is 200 millicoulomb, sorry, 200 millicoulomb, okay? So in this case, don't forget millicoulomb should convert to coulomb, because coulomb is international unit. If you have nanocoulomb, like first question, you have to convert to coulomb. In this question, we have millicoulomb should convert to coulomb also. So here the question is find the electric force. Here force unknown, force unknown. It's clear in order to find force you have to multiply E times Q. So in this case F equal E times Q, and instead of E, put 70 Newton over Coulomb times 200 times 10 to negative 3. Why negative 3? Because we have millicoulomb. When we convert to coulomb, should be multiplied by 10 to negative 3. So the answer is 40 Newton. The student free if he use calculator, no problem. Let we study another slide. Here, number 2, electric field at point. If you remember, we said with the point charge, the electric field non-uniform, the electric field non-uniform. So here there is a relationship between the distance which we need to calculate electric field in this distance with another distance. So here R, it is important factor. In other words, here around the charge point, electric field not same. It has changed from point to another point. For example, here, find the strength of electric field which due to a charge of 45 nanocoulomb at a point distance 50 centimeter. Here you ask about 50 centimeter. What does it mean? That is mean E it has special number when you change this distance. For example, if he ask about if he ask about 25 centimeter, the answer it will be different with 50 centimeter, with 70 centimeter. Why? Because R square inversely proportional with square of R. Okay, now I told you about 45 nanocoulomb should be converted to coulomb by what? By times 10 to negative 9. Here use the rule. Here E equal 9 times 10 to power 9. This is constants of Coulomb. Should be given in question. Here in the numerator 45 times 10 to power 9. Here this is amount of point charge divided by the distance, which is 50 centimeter, should change or convert to meter. So 50 centimeter 0.5 meter, half meter. The answer is 16.2 times 10 to power 2 Newton over Coulomb. See here the unit of electric field is Newton over Coulomb. Let we go to the another slide. Here we have homework here. Number 1, find number of electron in 5 microcoulomb. So we solved this question. Only you divide this charge 5 microcoulomb or any number divided by what? Divided by the charge of electron, which is 1.6 times 10 to power negative 19 coulomb. Then coulomb with coulomb delete, then it will be just number. So this is number of electrons. Question 2. Two charges, positive 20 microcoulomb and negative 50 microcoulomb. This is two charges look here positive and here negative, which are separated a distance 10 centimeter. So what is the question? Which type electric force? As we discussed today, if you have different sign charge, here positive charge, then negative charge, of course there is a attraction force between them. So this is type of electric force. The type of electric force is attraction force, because here we have positive charge and negative charge, because the rules said like charge repel, opposite charge attract. Again, like charge repels, opposite charge attract. B, calculate the magnitude of this force. He asked about force magnitude. You have to calculate this force by Newton. Use same rule, F equal, if you remember, F equal Kc, yes, Q1 times Q2 divided by R square. Yes, put instead of Kc 9 times 10 to power 9, put instead of Q1 20 microcoulomb, so 20 times 10 to negative 6. Also Q2 15 times 10 to power negative 6 coulomb divided by, here we have centimeter, 10 centimeter, should be 0.1 squared. Then use calculator to find the magnitude. Question 3. Find the strength of electric field due to a charge of 45 Newton coulomb at a point if the force in this point equals 60 Newton. Here, this question he asked about E. We need to what? We need to the general formula. I remember E equal force divided by charge. So here we have force and we have charge. Here E equal, to solve this question, put charge, put force firstly in numerator, 60 Newton divided by charge 45 Newton, should multiply by 10 to power negative 9 in order to convert to coulomb. Number, we have another question without number, so this is the last question. He started like this: find the strength of electric field which due to a charge of 45 nanocoulomb at point distance 50 centimeter. Yes, this question you need to charge point electric field, which is non-uniform. I mean, we have to use E equal Kc Q over R squared. Again, E equal, instead of Q put 9 times 10 to power 9, instead of Q put 45 nanocoulomb. Don't forget this is nano. You have to multiply by 10 to power negative 9 and divided by 50 centimeter. 50 is 0.5. It will be squared. I think that's all for today.